Hi, here we have honors algebra 2 math problem. So the question is solve to the nearest hundredth. So here we have to solve for x in the given equation to the nearest hundredth. Actually, the given equation is an exponential equation because we have variable x at the exponent. So whenever we have variable at the exponent, the equation will be considered as exponential equation. Okay, so whenever I'm trying to solve for a variable that is at exponent, so what I need to do is I have to get the same base on both sides of the equation. So once I get the same base on both sides of the equation, I can equate the exponents and I can solve for the variable. Okay, here on the left side of the equation, we have the base 11. Okay, if on the right side, if I have the same base 11, I can equate the exponent on the left side, the exponent on the right side, and I can easily solve for x. But we don't have the same base 11 on the right side. Is it possible to write this 4.75 in terms of base 11? So for that, 4.75 has to be a power of 11. I don't think 4.75 is a power of 11. So easily we cannot convert this one in terms of base 11. So when we have this kind of situation in exponential equation, we have to use logarithm to solve for the variable. So that means we have to take logarithm on both sides. So when I want to take logarithm on both sides, I may take either natural logarithm or common logarithm. Common logarithm is the one which is having base 10. So because in our calculator we can get value of logarithm. So when it is natural logarithm or common logarithm. So that's why I'm saying that we have to take logarithm on both sides. So the logarithm has to be either natural or common. So here I'm going to use a common logarithm on both sides. I mean the logarithm with base 10. So I'm taking logarithm with base 10 on both sides. So I have taken common logarithm, that is logarithm with base 10 on both sides. Okay, now I have to use the properties of logarithm and solve for x. So here, when I look at the argument of the logarithm on the left side, it is exponential. So whenever the argument is exponential, the exponent we have over here can be moved in front of the logarithm using the power rule of logarithm. So, so this x can be moved in front of the logarithm and it has to be multiplied by the logarithm. Log 11 to the base 10 equals to log 4.75 to the base 10. Okay, now, so I moved the exponent x in front of the logarithm using the power rule of logarithm. Okay, to solve for x, I have to get rid of this log 11 to the base 10. So I divide both sides by log 11 to the base 10. So this one will cancel out. I get x equals to log 4.75 to the base 10 divided by log 11 to the base 10. Okay, now we can use calculator to get the value of this log 4.75 to the base 10. So the value of log 4.75 to the base 10 is from the calculator we get 0.67669 and it keeps going. So we can round it to 5 digits after the decimal point. And the value of log 11 to the base 10 can be as 1.04139. And this one also keeps going, but we can round it to 5 digits. Okay, now I have to divide 0.67669 by 1.04139 using our calculator. Then I'll be getting 0.64979. It keeps going. Anyways, we have solved for x, but we have to give our answer to the nearest hundredth. So when I want to round this value to the nearest hundredth, I have to look at the digit at the thousandth place. So because this is 10th place, this is 100th place, and this is thousandth place. Okay, so when I look at the digit at the thousandth place, it's just 9. If the digit at the thousandth place is 5 or greater than or 5, what I need to do is I have to add 1 to the 100th place. So then I'll be getting 0.6. When I add 1 to 4, it will be 5. I can ignore the rest of the digits. So I've rounded this value to the nearest hundredth. So the value of x in this in the given equation is 0.65.